Unit 1 Chemistry, Chapter 5, Part 2. Now we're looking at the mole. Now the mole is a very useful unit in chemistry. It's a way of measuring or counting the number of particles at the subatomic level, so the number of atoms or ions, or even potentially the number of protons in there, in an absolute number without using ridiculously big numbers. Okay? A lot of the properties or things about the reaction will depend on the number of particles you've got in a substance, not its mass. Okay, so for instance, the ratio in which they're going to react, what we see in our equations, that is based on the number of particles. So if you want to know how much you've got to react it with, you need to know how many particles you need, not the mass. Okay, we can calculate the number of particles by weighing, or we can calculate the mass that we need using the number of particles. There is a relationship between them. So, to relate it to mass, we will look at the atomic mass of a substance. Okay? If we take the atomic mass of it and convert it into grams, that is the mass of 1 mole of the substance. Okay? So carbon, we know, has a relative atomic mass of 12.01 atomic mass units. 1 mole of carbon, therefore, is going to have a mass of 12.01 grams. Okay? If it's a compound, it's the same as working out the molecular mass or the formula mass. You add together all of the elements that are in there. Yeah, but instead of expressing the answer in atomic mass units, we're expressing the answer in grams. Okay? That is the mass of 1 mole. If someone asks you for the molecular mass, okay, then that is how much does 1 mole weigh. Okay? You'll sometimes see the units expressed as grams per mole. Okay? Now, when we've got this, there's a few things we can do with this mole. We can use it to count by weighing. So we weigh it, we know its formula because it's a pure substance, and then we can find the number of particles of each sort. We can also use the molar mass to find out what percentage by mass of an element is in a particular compound. Okay, so we can say, for water, we can look at it, we can work out what percentage is hydrogen, what percentage is oxygen by mass. We can also use it to work out these formulas, whether they're empirical formulas, which is our simplest whole number ratio, or whether it's molecular formulas, which is how many there actually are in a molecule. Okay, what a mole actually is, we've said it's a counting unit. It is a counting unit. It counts a very big number. So whereas a dozen tells you that's 12 or something, if we say there's a mole of it, what we mean is 6.02 times 10 to the 23 of it. Okay, what it is depends on what your question is. So it might be the 6.02 times 10 to the 23 atoms, or molecules, or ions. Depends what we're looking at. This number here is known as Avogadro's constant. Okay, after a gentleman called Avogadro who first determined it. So if we have a mole of hydrogen, then there are that many atoms of hydrogen. If there's half a mole, there's half the number. If there's 2 moles, then it's double that.